So now that you know what Backus Naur form is, let's apply it to translating code into Backus Naur form rules. The learning goal here is to do just that, to use Backus Naur form rules to create grammars that describe the syntax of programming languages. When designing a programming language or a compiler or interpreter for a programming language, what are the building blocks for your program? We've already learned about statements. These are parts of the program that have side effects. And expressions. These are the parts of the program that have return values. We can represent these using the symbols stm and exp. We'll define Backus Naur form rules for these in a later video. We can have var, which defines legal variable names, and num, which defines legal numeric values. We already know how to make regular expressions for these. Let's say we wanted to represent a while loop using B and F rules. This isn't too difficult. A while loop can be described using the following rule. Anytime in a program when you can create a statement, that statement can be a while loop. A while loop consists of the terminal symbol while, which is just the word while, and an expression, followed in Python by a colon, and then a statement. The statement is what occurs inside of the loop. Let's consider something a little bit more complicated. How do we represent a list comprehension? This is an example of a list comprehension in Python. It has a lot going on in it. It has two different lists, E and F, that we're drawing elements from, X and Y, and two filters, X greater than 2 and Y less than 7. And then, as the final result, we take X plus Y and put each X plus Y in a list and return a list. Since a list comprehension returns something and doesn't have any side effects, it is an expression. So anytime we could have an expression, we can have a list comprehension. A list comprehension begins and ends with a square bracket and starts with an expression describing what's going into the list. In our example below, the expression is X plus Y. This is followed by something I'm going to call map. And map is the part that does the for X and E, for Y and F. Then that's going to be followed by filter, which does if X greater than 2, if Y less than 7. So let's define map and filter. Importantly, these are not the functions map and filter. These are non-terminal symbols that I just happen to have decided to call map and filter in order to keep track of what they do. The first rule for map is that we can have as many maps as we like. As long as we have at least one, we're good. Map can be defined as for variable in expression. And if that expression returns a list, we won't get an error message down the line. Filter is, like map, something you can have more than one of. But unlike map, we can have no filters if we choose. The syntax for filter is if and then an expression. So, the trick to describing a programming language in terms of Backus Naur form rules is we take the building blocks of programming languages, statements, expressions, variables, numbers, and other things, and build a grammar with these pieces and other non-terminals and terminals you define.